Seriously, do you believe that your Salesforce code is secure? Let's take a standard Lightning Web component, which displays a list of users that meet certain criteria. This component, if Lightning Web security is enabled, will be wrapped in a proxy object, which allows the LWS engine to determine what you can see and modify in this component. I explained this in more detail in another video, the link will be in the description. That is, you can say that your interface is kind of secure, but let's not forget that this component also calls an Apex controller method in order to get user data. This request is sent over HTTP, usually as a post request, when you specify the name, class, method, parameters, and additional elements such as a token. This all happens behind the user interface, and therefore it looks like it is safe. But it's not. The fact is that if anything involves HTTP request, it cannot be safe for 100%, because those requests can be intercepted, modified, and sent with different parameters. So today let's take our Find the Guilty application for practical vulnerability testing and try to hack that machine. Shall we? This is the interface we have at the moment, separate functionality for reviewers and administrators. But let's take a look at this interface exclusively from the reviewer side. The reviewer actually has only one tab, Find the Guilty Reviewer, where displayed all active review processes. In the browser console, if you go to the Network tab, you'll see every HTTP request that is sent with all the details. Here we can sort all of them by the keyword Apex, which will show us the calls to our controllers. At the moment we have only one to get a list of all active review processes. And here we can see what parameters are passed right here, which are status and user ID. And here I clearly see the first problem, is that we allow some kind of dynamism in the request, namely passing status. For what? I mean, I know sometimes it's tempting to create one Apex controller method that handles several scenarios, but what can this lead us to? So I have all the details of this call, including the token and everything that needs to be included in this HTTP request. So what I'll do is go to the console, and here I already have the code prepared in order to simulate this HTTP call. So grab it, here we are. Right here I need to specify the class name, which I can easily find in the original request. Just copy and paste it back. Same with the method name. If I go back to the Network tab, here I see the name, so I'll just take it from here and paste it in our fake request. The parameters are probably one of the most vulnerable elements, because I can change them to whatever I can think of. In this case we have two of them, status and user ID. User ID I'll copy as it is in the original parameters, I don't know really those IDs, right? And the status I'll change it to some other value, for example draft, probably one of the most common statuses. Now the most important thing is the payload of this request, which again I can easily see right here with all the details that can be. So we simply move back and forth and copy all the values from this request into our fake request. That's pretty much it. We copied all the details of the original request and changed the status from one to another. Let's try to execute it and see what we get. This is the result we get. Here we are looking for the return value attribute, which is right here, and it is empty, unfortunately, but we don't lose hope. Let's go back and let's change the status from draft to completed. That's the second most popular status that comes to mind. Execute it again, and now we already have some kind of response. Let me copy it and format so we could evaluate if there is anything useful here. Well, at least we already gotten what we shouldn't have gotten, right? Here I can see the name, the number of review records, and I also see a whole array of all child records. I also understand that this review process was carried out on contact records, but most importantly, I see all the IDs. This is already a good start, as I'm sure I can use it somewhere else. The ID is probably one of the most popular parameters passed from the Lightning components to the Apex controller. So this opens the door to testing a much larger scope of methods. That is, now with fairly simple manipulations, we can now pass various parameters to the HTTP request and try to get some things that we shouldn't get. And this sounds like a problem with my Apex controller method and selectors and generally the code structure, which it is. But if you believe that's the only area of concern, you're wrong. Because despite the fact that my code sucks, Salesforce sends hundreds of those HTTP requests to get data for your record detail page, list view, or really anything else. And therefore, it's not just about my custom code. It's about how you handle sharing model in Salesforce. You're all familiar with such a sharing model in Salesforce. These are standard rules that are imposed on your users and determine which records they can see. And most importantly, this model can only extend access. For example, if you have an account object that is specified in organization-wide settings as public read-write, there is nothing that will stop this sharing above, only extend. The only element that is omitted here is profiles and permission sets. If you have not specified any access to account in them, then it will not be visible for those users at all. But this is no longer about sharing, right? But rather about access to the object itself. As soon as this object access is granted, this model comes into play, which determines which records the user can see and edit. And I only say this for the reason that even if you handle your custom code perfectly, if-else condition where this set of records should be returned back, when it should not, it doesn't mean that you are safe, because any Salesforce standard HTTP request can also be manipulated, and it will no longer take your custom condition into account, but will return everything that was defined by the sharing model. If the sharing model sucks in Salesforce, potentially can you. So let's confirm in our application what's happening with the sharing model. As you remember, we were able to get and manipulate the review process records, so let's look at our organization-wide settings for this S object. For this, we go to the sharing settings and look for our S objects right here, here it is, and it's listed as private, which is a good start, meaning that primarily users will only have access to the records they have created. Now let's see if there are any sharing rules for this S object to make sure that we are not extending this access too far. In our case, we don't have any sharing rules at all, meaning we are not extending the primary private access, which means that the users still only have access to the records they have created. Another element is the sharing of the records by role hierarchy. If you scroll up, you will see that this checkbox right here is activated, which actually means that there is a certain expansion of access for some users. For example, if a user has a role CEO, then he will see the records that were created by users whose role is child of this one. That is, all this one. We don't need this in our case, so let's deactivate this checkbox. I want access to remain private. All child S objects, such as review feedback and review feedback items right here, are listed as controlled by parent, which effectively means that only when you have access to the review process, you will have access to this child records. This is exactly what I need in this case, so no changes are needed here. So our sharing model looks good. All records are private, only the person who created them has access to them, which makes perfect sense to me. But still, at the beginning, we were able to get records which I definitely did not create. So why was I still able to access those? This is where your custom code comes into play. In general, when you create your Apex class, you mark it with 3 keywords. With sharing, when you want this class to take into account the Salesforce sharing model. That is, any SQL queries you have will return only those records that the user has access to. Without sharing, when you want this class to sneeze at the sharing model and get all the records that fall under the criteria of your SQL queries. Inherited sharing, when you want this class to have the same sharing that the class that calls it has. That is, if the class with sharing calls it, then this inherited sharing class will have the same with sharing. In the case of inherited sharing, you might wonder what happens if I call this class from a Lightning component. In this case, it will be positioned as with sharing and will take into account your sharing model. Also, with sharing will be default if this class is called asynchronously or as a REST API service. In fact, in all cases when there is really no parent class that calls this class, its sharing will be marked as with sharing. You should always stick to those keywords when creating an Apex class, but sometimes, you just want to specify nothing. I mean, literally nothing. If you create a class and do not specify any sharing keyword like this, then this class will behave like you specified with inherited sharing. It will still take the sharing of the class from which it was called, but there are nuances. If this class is called from a Lightning component, it will have with sharing by default, just like the inherited sharing class. Everything is fine here. But if the class is asynchronous, or it's being used as a REST API service, or even if you call it from a Visualforce controller, in all these cases it will be without sharing by default. That is, in these cases it will not take into account the user sharing and will get all the records. It is generally accepted practice not to do so. Always provide some sort of sharing for your class so that you have an idea of what to expect. Now let's go back to our Find the Guilty application and understand why what is happening is happening. That is, we know that the sharing model looks correct and still we could simulate the HTTP request and get records that should not be visible. So why? Well, first of all, as I noted, this dynamism in this method right here doesn't make any sense. It only opens up more possibilities. I would call this method get ongoing review processes and call it a day. Nevertheless, regarding sharing, here this controller is specified as without sharing, which is bad and yet not critical, since the controller doesn't have any so-called queries, right? They are all somewhere in the selectors. So let's look at a selector review process selector, and it doesn't have any keyword, which means that it will take the one that is in the controller, which is without sharing. And this is already a serious problem. Here I need to either mark this selector as with sharing, then the parent one will be ignored, or specify the controller as with sharing, then this selector will also be with sharing. But I'll do one better. I'll mark both of them as with sharing, and right here I'll define this selector as well as with sharing. Keep everything with sharing. We know that our Salesforce sharing model looks completely right. I'll better manage it on the sharing rules and restriction rules level. Additionally, I remember there is a problem of overfetching in this selector. That is, as you remember from the results we got, I got a lot of information. Also, from the interface perspective, I clearly didn't need all of this. Here the problem is that my selectors are poorly organized, right? So what is the solution? GraphQL. Just kidding, enough GraphQL for this channel for now. So where we are. We fixed our sharing model in Salesforce, we added with sharing to our controller and selectors, and still there is a problem with overfetching, which I would also relate to the vulnerability problems, right? So what we can do here, as I mentioned, we might need to restructure the code and my selectors, because it sucks. But another thing is we can take field level security, or FLS, into account. That is, whatever we discussed so far was related to which records the user can see, right? It has nothing to do with which fields they can see. So to take this into account, you need to add with user mode to your so-called query to take FLS into account. But again, this is probably a topic for another video. For now, don't forget to subscribe to the channel, leave a comment about what you think, share some insights, and I'll see you anytime soon.